we want to talk about, for what chapter is this? Chapter 18. Chapter 18, we want to talk about F and E. And this is all in the recorded lectures that you should have watched, so this is just a very, very quick review. F, what does F stand for? Force. And in this case, we're talking about electric force. Electric force, due to Coulomb's law, is F equals K times Q1 times Q2 over R squared. And this is the force between any two charges. So I can have a positive charge here, I can have a negative charge here, separated by some distance r, and I can calculate what the force is between those two. Now the force between these two, the direction that it acts, it depends on which charge you're talking about. Right? In physics 1, it was pretty clear, oh, this force is acting to the left, this force is acting to the right, this force is acting up or down. Here, these forces, it depends on which one you're talking about. So the force that you're talking about with Coulomb's law is either attractive or repulsive. The force that these two experience relative to each other, are they going to attract each other or repel each other? Why? Because they're oppositely charged. So this charge, this positive charge, what direction is it going to move? What direction is the force on this? What direction would that be? To the right. Maybe if we used x and y, positive x, perfect. So that would be the positive charge. How about the negative charge? What direction is that force going to be? That's going to be to the left, negative x. Okay. So the direction depends on which charge you're talking about. So you got to do some physics to figure that out. It doesn't just fall out. And to find the magnitude, F equals KQQ over R squared. Okay. Yes, F equals KQQ over R squared. Okay. So the positive charge would have a positive force. The negative charge would have a negative force because it's going in the negative direction. I could just as easily have drawn this so that I have a negative charge here and a positive charge here. So the negative charge in this case is going to be attracted to the positive charge, so the negative charge actually has a positive force because it's moving in the positive direction. Opposite for the positive charge. Okay? So direction always comes from looking at the signs of the particles. Like charges attract, opposite charges repel. Okay, so that's how we can calculate forces. But what we also want to do, aside from forces, is we want to talk about E. And what is E? F was force. E is something kind of new. Is electric field. In physics 1, you learned about gravity. Gravity is a field force. Gravity is like the electric field. It just kind of exists. So gravity tells me what will happen if I drop this rod. What's going to happen? It's going to fall. Sure? Pretty sure? Would you bet your grade on it? Yeah? That would be a good bet. It's going to fall. Because there's a force that's acting on it, that's pulling it up. Can you see anything interacting? Nothing causing that? We can't see anything. Same thing with the electric field. Every charge has a force that's associated with it. If you have a positive charge, what direction does the electric field go due to a positive charge? Does the electric field go toward positive or away from positive? It goes away from a positive charge. So electric field from this positive charge is going to go up, going to go over, go away, and go away. Okay, so every charge creates a little electric field, and if it's positive, it goes away from it. If it's negative, it goes towards it. So I can have a negative charge, and it could go towards it. Let's say that this positive charge has a charge of Q, and this negative charge has a charge of negative 2Q. So right away, my picture is wrong. What's wrong with my picture? I've drawn some things. I've drawn these field lines. Those are important, right? What do I need to change about my field lines to make the picture right? I have to double the number of lines I have here. So how many more lines do I need to draw here? I draw 4 more. What if I made that charge, oh, I don't know. Let's make it 4Q. How many lines would I have to draw? I have 4 lines here, so how many lines do I need here? 16. That'd be a pain in the ass to draw. So if I asked you this on an exam, you could attempt to draw 16 lines, or you could just say 16 lines going in, you cruel a-hole. That'd be mean to ask you to draw 16 lines. That's just super repetitive. Okay, so that's electric field. Electric field, there are ways you can calculate the electric field. I can calculate the electric field that a charge feels due to another charge by using electric force. E equals force over charge. Okay, so that's the electric force, that electric field that a charge we feel inside of an electric force. And what was the equation for electric force? What's Coulomb's law? K times Q over R squared. So I have another Q, and two of the Q's cancel out. So I can get another equation for electric field, KQ over R squared. And I can also see what the units are of electric force, electric field, by using the units of electric force. What are the units of electric force? Units of electric force. What are the units of any force? Say it louder. Newtons. And what are the units, SI units of Q? C, which is coulombs. So electric field units are newtons per coulomb. So a brief notation kind of thing. This is kind of standard in physics. If you put something into brackets, so I have this E in brackets, that brackets means I'm talking about the units of that quantity. So the units of the electric field are newtons over coulombs. So let's do a little brief review of all the units that we know now. Units of force, what are those? Newtons. Let's do units of charge. What are the units of charge? C, which is coulombs. And then what are the units of R? Of distance between two things. What should I use? Meters. Okay, so these are, some of these are units that you've learned about already. Newtons and meters. Coulombs are going to be new. An electric field, the fact that it's newtons over coulombs is new. Okay. So that's electric field. Last thing to give you a little hint about to help you with homeworks, potentially, we take two charges. And anytime you have a kind of situation like this, you want to draw a picture of what's going on. We'll leave it up to you. What do you want to make the sign of this charge? Do you want to make this positive or negative? Positive, okay. Do you want to make this charge up here positive or negative? Negative? Okay, so we'll make this negative. What you're going to do, let's choose a coordinate system, an origin for everything. Let's make this our origin. So we're going to draw axes. We're going to draw an x-axis and a y-axis. So that gives us a frame of reference for everything that we're going to do. Let's identify the forces that are acting on this. So do you want to do the forces acting on the positive charge or the negative charge? Which one? You're going to do the negative charge? Okay, so we're going to talk about where is the negative charge going to go due to the positive charge. So if I were to draw this force vector, where would it go? Go towards positive or away from the positive? It's going to go towards, because it's an attractive force. So we have an attractive force. Let's call this positive charge, charge 1. Call the negative charge, charge 2. So let's call this force, force of charge 1 on charge 2. That force, is it acting entirely in the x direction? Is it entirely horizontal? Is it entirely vertical? It's acting at an angle. In physics 1, what did you kind of have to do every time something was acting at an angle? Find both x and y. So you have to break this up into components. You have to start doing trigonometry. So you have some piece of this going in the x direction. Let's call this f, y, and some piece going in the x direction and y direction. So we have some piece going in the x and some piece going in the y direction. And we can calculate all of these things. Let's say I knew this angle. Let's say this angle is 30 degrees. I could do all sorts of trigonometry here to figure these things out. This is all stuff we should remember from Physics 1. If you don't remember this, set up some office hours, shoot me an email, and I can go over things in more detail next class. But this is kind of review stuff, hopefully. But again, if not, if Dr. Iyer didn't cover this, you just need to tell me. Okay. So if I wanted to calculate these things, I could calculate these things using all sorts of trigonometry. Let's see, what's the relationship? Let's see, if I wrote the tangent of 30 in this triangle that I've drawn, what would the tangent of 30 be? So what's the opposite side? Fx. What's the adjacent side? Fy. If I did cosine of 30 in this particular triangle, what would that be? I take the side that's adjacent to my angle, so which side is adjacent right next to my angle? That would do Fy. Over the hypotenuse, what's the hypotenuse? The force between charge 1 and charge 2. So that's kind of the structure we follow to kind of solve problems when you have forces acting at angles. Any questions on any of this? Okay, so we'll give you until 12 o'clock to work on the homework problems, work together in groups. And at 12 o'clock, what we'll do is I'll come to each group and we'll figure out if there's any problem in particular that you'd like me to do on the board. And I will solve a problem at noon for you if you'd like. If not, then you'll be ready, you'll be free to leave. Sound good? Okay. So that's basically what the class structure is like. I might do some demos. I'll do a little demonstration.